Okay, so today we're going to talk about ways to separate out a mixture, and here are the different examples that you could have. So we have phases of matter. For the first example, if we were to have a solid and have that mixed in with another liquid or an aqueous solution, how would we separate that? Well, the best way to do that is using filtration. So if we use filtration, this will work well to separate out a solid from either a liquid or an aqueous solution. Like if I were to have some sand and then I were to add that to a solution of salt water. Now, if I were to have something like, ink pigment, the best way to separate that would be if I were to use something like chromatography. So now with the ink pigment, you have the two liquids that are combined together. And what the chromatography is doing is you're applying the idea that these two liquids, they have different masses. So based on the size of the molecules that are in the ink pigment, they will separate out differently and they will move along the chromatography paper differently. I'm going to write out what the chromatography paper or draw out what the chromatography paper looks like, and this way you can kind of see how that would work. You've done a lab like this. Like in biology, you did a lab, I think it was Botanis Curis, they did this lab with you, and they gave you these pigments from a tree, and they wanted you to separate them out. You had to run them on a piece of paper. They separated out into their colors. So that was the chromatography lab that you did back in 8th grade. And then what if you have two liquids? Well, if you want to separate out two liquids, the best technique to do that would be if you were to have a distillation apparatus. And I have a picture of this below. I'll show you what this looks like. But an idea would be if you wanted to separate out like alcohol and water. So a lot of times people want to purify the alcohol from water. They want to get a pure alcohol sample, so they'll run it through what's known as a distillation column. So what are the properties that they're applying in each of these? Well, when we look at something like filtration, the property that we're applying is the fact that there are different phases of matter. We're also applying the idea of particle size. So sand, for example, is a much larger particle size than something like, water or the salt dissolved in the water. And so it will get caught in the filtration or in the filter paper. The salt water will go through, and then you'd have to then purify, the salt from the water. With the ink pigments, here with chromatography, we're applying the idea of different masses and also different what they call polarities. And when we have something like distillation, we're applying the property of different boiling points. And also different polarities again. Now, I don't really expect you to know what polarity is just yet. We're going to do a whole chapter on bonding soon, and so you'll know about what's known as molecular polarity. But the property of polarity, it determines things like boiling point. It determines how well it will adhere to paper, for example, and so that's what I mean by different polarities. So let's take a look at the distillation apparatus down below here. So this is showing you a distillation apparatus. I'm going to actually do a demo with cherry Coke. I'm going to isolate out the cherry flavor for you from the rest of the soda. And so here you would start on the left here in the flask. And this would be my mixture. So here's my mixture in the flask. And I'm going to heat this mixture. Now what's going to happen is it's going to get hot, and one of the substances is going to start to boil before the other substance does. So that first substance is going to start to boil, and as it boils, it's going to form gas within the flask here. that gas is going to rise up this fractionating column. As the gas rises up the column, and it will travel through this tube, it starts to cool down. As it cools down, it will recondense. So it'll recondense back into a liquid. And now we can separate out this pure liquid over here. So my mixture can be separated out based on the boiling points. You'll have the mixture that you started with on the left separated into the two liquids. One of the liquids will stay behind in the flask. The other liquid will be collected in this flask over here. So this is my end product here. Sometimes they call this the distillate. Now just to show you a little bit more about chromatography, the simplest kind of chromatography, and I'm going to insert a page right here, the simplest kind of chromatography that you can do is a paper chromatography. And so with paper chromatography, you would have your piece of paper, and this piece of paper you would partially submerge some kind of liquid, usually water, although you can use other types of liquids depending on what you're trying to separate. And if you remember from back in biology, which you probably don't, but just in case you do, you started off with a mixture of pigments. And so it almost looks like it's just black, because they're all kind of mixed together. And what would happen over time, if I copy this, and I paste it over here, what would happen over time is that this black pigment would separate out into its individual colors. And so over time you would get this. If we erase that, and we put back in our water, you'd get pigments that would separate out. So you'd have one mark up here. Maybe you'd have a different color here. And maybe you'd have another color here. So you'd get these different colors that separate it out. And this tells us a number of different things about the molecules that make up the colors. The first thing that it tells us is that the blue dot, or the blue dye we'll call it, this moved the furthest. And it did so for two reasons. One, it might have been the smallest. So out of these three different pigments, the blue was the smallest. And then the second thing is, it didn't have a very strong affinity to the paper. So it didn't stick to the paper. And so because it didn't stick to the paper well, it was able to rise up the paper more than the red or the yellow color. So those are my separation techniques. What I want to tell you about now is physical and chemical properties, physical and chemical changes too. So a physical property, it is defined as a property of a substance that can be determined without changing the chemical makeup of that substance. A chemical property, on the other hand, is a property of a substance that has to be determined by seeing how it interacts with other substances. How does it change when it's put in the presence of other substances? So if I was going to put down a chemical property, it's the opposite of that. It's a property that is determined by how a substance behaves in the presence of other substances. So what are some examples of each of these? Well, a physical property, you can just look at the substance and see what the properties are because you don't really have to change it in any way. So this would be something like, for example, if I was looking at this and saying, well, is it shiny? Does it have luster? What's its mass? What's its volume? What's its density? Some weird ones that you probably haven't heard about, ductility. Another one, malleability. Ductility means to be made into a wire. Ductility means to be hammered into sheets. So those are properties that are really common to metals. And then we have the chemical properties. So those are, again, how a substance behaves in the presence of another substance. So what would some of those be? Well, that would be, is the substance flammable? Does the substance corrode? Does the substance, is it non-reactive? So those are some chemical properties. Now physical properties, those can actually be divided up into two types, intensive and extensive. And if you're an intensive property, I think of intensive, you're independent of the mass or amount. So that would be something like density, boiling point, melting point. Extensive is something that, actually another intensive one would be like solubility. Extensive would be dependent on the amount. And so that would be like mass, volume. So those are the physical properties. Let's talk about physical changes and chemical changes. So physical changes, so you change the appearance of a substance, but not its chemical composition. In a chemical change, you change the chemical composition. So take, for example, water. If I had H2O solid, a change to this where it would change its appearance would be if it became H2O liquid. This would be melting. A chemical change would be if I took the H2O and I was able to change it back into its elements. I decomposed it into hydrogen and oxygen. This would be a decomposition. So when you undergo a chemical change, you're looking for new substances being formed. When you undergo a physical change, it's the same substances. So, same substance. So physical changes, it's all phase changes. All phase changes are physical changes. Dissolving. If I dissolve salt in water, it's a physical change. Any sort of thing where I, change something, just its appearance, not what it actually is made up of. Chemical changes, so we have a decomposition here. If you have an acid and a base, they can neutralize each other, so neutralization. You could have rusting, corroding, combustion, so these are the substances, these are the changes that are chemical changes. This is when a substance will undergo a change that will completely alter what it's chemically made of. And so, for example, with rust, just to show you one example of this, you have iron. You can combine it with oxygen in the air, and you'll make rust, Fe2O3. So these are the notes on matter. We've done density and specific gravity in class. We'll practice some problems on that. But these are the notes on matter. Next time we'll do notes on heat, heating curves, cooling curves, heat transfer, how to measure heat energy, things like that. All right, thanks so much.